So I'm just going to talk about very basic idea for rational functions. And whenever you hear the word rational function, you should just think of a function with a fraction in it. So the simplest idea would be a function that looks like f of x is 1 over x. And before I show the graph, I want you to think about what we're doing is we're taking each x value and we're figuring out what do you get when you go 1 divided by that x value. The answer you get is the y value, okay? So for example, if I do x equals 2, then I have it 1/2. So my y value is going to be 1/2. Some of you guys like decimals, so we'll make that 0.5. If I did f of 10, that's an x value of 10. That's a y value of 1/10, or 0.1. If I did f of 100, 1 out of 100, 0.01. Okay? So what I hope you can see is that as I make x bigger and bigger and bigger, my y values get smaller and smaller and smaller. Okay? F of 1,000 would be 1 over 1,000. That's even smaller. Okay? So what I'm saying is that as I make x bigger and bigger and bigger, what happens to my y value? My y value gets smaller and smaller and smaller. Now, what is it getting closer and closer and closer to? Well, it started here in my examples at 0.5, then 0.1, then 0.01, then 0.001. As x gets bigger and bigger, my y's get closer and closer to 0. Okay? Are they ever going to reach 0? No, they don't actually reach 0. They just get very, very close to it. So we'll start with f of x equals 1 over x. And you can see that as I slide along each x value, I go 1 divided by that x value, and I get the y value. As I keep sliding to the right, you can see my y values are getting smaller and smaller and smaller. My values are super small here. Are my y values ever 0? Nope. That's called a horizontal asymptote. The horizontal asymptote, I didn't mean to change colors, but that's okay. The horizontal asymptote is y equals 0, because that's the line, y equals 0, that my graph is approaching. Now you might notice my graph also has a left side on it over here. That is because if I change my x value to a negative, that changes my y value to a negative as well. If I plug in negative 10 and I do 1 divided by negative 10, I get negative 0.1. Negative 100, 1 divided by negative 100, negative 0.01. So now we can say that as x approaches negative infinity, the f of x approaches, some people might write negative 0. That's fine. There's really nothing wrong with writing negative 0. Most people just write regular 0 because negative 0 and regular 0 are the same thing. There's no difference. 0 is neither positive nor negative. So there's no difference between negative 0 and positive 0. So there's some nice symmetry here. Whatever happens in the top right corner also mirrors itself down here in the bottom left corner. And the idea is just that dividing by a negative number gives you the same answer as dividing by a positive number, but it's just flipped over because it's negative instead of positive. You might notice there's also a vertical asymptote right here. Okay, and that's a vertical asymptote. And instead of it saying where y equals 0, the vertical asymptote is where x is equal to 0. Now let's think about why that's true. I can plug in x equals 1. I could do 1 divided by 1. I can plug in x equals 1/2, and I could do 1 divided by 1/2. That would give me an answer of 2. I could do x is 1/10, and I'd get 1 divided by 1/10. Okay, and I could go closer and closer. But there's a single number that I can't divide by, and this is the biggest concept for rational functions, is that there is a number you can't divide by. You can't divide by 0. If you tried to take one thing and split it up into 0 groups, you cannot do it. You cannot take one thing and slice it up into 0 parts. You can take one thing and slice it up into 2 parts or 10 parts. You can slice things up into fraction parts. You can slice it up into parts that are 1/2 each, and then you have 2 of them. So it's possible to divide by big numbers, small numbers, negative numbers. It's possible to divide by fractions and decimals. It's just not possible to divide by 0. So when you have your function like this, the only thing you need to worry about is dividing by 0. So 1 divided by 0 doesn't work, and that's why that's a vertical asymptote at x equals 0. X equals 0 is the only number that you can't plug in. Okay, so this is your parent function. This is what everything else is based on. Now, you can try other functions that have some variations on them. Like, instead of 1 over x, what if we did 3 over x? Pretty much the same. The only difference is every y value is 3 times higher than it used to be. So here we got 1 comma 3 on the blue graph. Because if I plug in x equals 1, 3 divided by 1 gives me a y value of 3. And we have 1 comma 1 on the red graph, because if I plug in x equals 1, 1 divided by 1 is 1. We can do more complicated things. We could do 3 divided by x plus 2. Now look at what happened. Instead of the horizontal asymptote being y equals 0, now the horizontal asymptote is y equals 2. I'm going to turn off some of this stuff so it's not so cluttered. Do you see how my blue graph and my black graph are the same shape? My black graph is just slid 3 boxes up. You can even do things like this. Let's go 3 over x minus 1. Now, I'll turn off the black graph. You can see that this new graph, let's make you purple. My purple graph is now 1 step slid to the right of my blue graph. And instead of that vertical asymptote being at x equals 0, now my vertical asymptote is at x equals 1. Okay, so I just wanted to show you in detail that 1 over x example. I need you to understand why the points look the way they do, why there's a horizontal asymptote, and why there's a vertical asymptote. And then I just wanted to show some simple moves where, okay, you can slide it left or right, up and down, and start talking about how the asymptote moves when you change the equation. We'll dig more into that in another video. Let me know if you got any questions.